Thank you, Jerry, and thank you, NewEra Software, for sponsoring the zExchange and these crypto sessions on System Z. This is our eighth in the series, and this month we're going to turn our attention a little bit more to the operational aspects of running your crypto environment. We're going to talk about master keys and the process for loading those master keys and making them available so you can run your cryptography workload. Let's go to slide 2. Uh, as as you're probably aware, I retired from IBM back in April. The material and the stuff we're going to cover today is based on the work that I've been doing for the last 10 years for the Washington System Center and IBM and supporting cryptography on Z. On slide 3, we're going to quickly cover some basics this morning, kind of level set everybody, make sure we're starting at the same point. Some of these slides will look a little bit familiar, but hopefully we'll go through those very quickly and then get into the process of creating and managing and loading your master keys to get your environment up and running. And then finally, we'll give you some things to think about as you're developing your policies and procedures for managing your master key material. Let's go to slide 4. So the IBM hardware has historically been characterized as either clear key or secure key. With clear key hardware, the hardware expects to receive the key material in the clear. That is, if you have a symmetric key of ABCD, then that value of ABCD will probably exist in storage or in a data set in a key store somewhere in the clear. And anybody that can look at storage could see that key value. Anybody that can look at the key store could see that value. Secure key, on the other hand, says that the only time your key material, your operational keys, your symmetric keys exist in the clear is inside the tamper-resistant boundary of the Crypto Express card. So if you want to store a key in a key store, before it's moved to the key store, it will itself be encrypted under another key called a master key. So you can imagine that it's critical that that master key material be available when you want to protect the key to put it in the key store, and then when you take it out of the key store and want to use it in your hardware. So we're going to talk about that process. Now, protected key is fairly new. It came about with the Crypto Express 3 and HCR 7770. We're not really going to talk about protected keys today other than to say that a protected key, when it's stored in a key store, is stored as a secure key. So that protected key will be encrypted under the master key. So everything we're going to talk about today applies to both secure keys and protected keys. We're not going to spend a lot of time talking specifically about clear key or protected key. We're going to focus in on secure key and how you load those master keys to protect that secure key material. So let's go to slide 5. There's 3 key stores that ICSF uses. The CKDS, or cryptographic key dataset, is where we store symmetric keys. Whether they be triple DES AES keys that you would use to encrypt data and decrypt data. There's other types of keys. PIN keys rely on DES encryption as well. Importer-exporter keys are just another type of symmetric keys. And there's a host of other symmetric keys defined or described in the ICSF System Programmer's Guide. All of those key types are stored in the cryptographic key data set. If it's a clear key, it is stored in the clear in the key repository. If it's a secure key, it's encrypted under that master key. Similarly, the PKDS, it's a PKA, or public key architecture data set. That's where we store public or public-private key pairs. Public keys are going to be stored in the clear. You're going to publish them anyway, so they don't need a whole lot of security around them. They just need to be available when you need them. Private keys, on the other hand, if you remember when we talked about asymmetric encryption, with a private key, you're the only person that will ever use a private key. You don't need to share that. You don't want to share that with anybody else. So private keys stored in the PKDS will be encrypted under the appropriate master key, the RSA master key for RSA private keys and the ECC master key for ECC private keys. Finally, the TKDS, the token key data set, that's where we store cryptographic objects that are associated with the PKCS11 architecture. So you can have either clear keys or secure keys stored in the TKDS. That's effective with the Crypto Express 4S and HCR 77ABLE0. So if you have key material that's going to be used in a PKCS11 architecture operation, it'll be stored in the TKDS in the clear if it's a clear key, and if it's a secure key, it'll be encrypted under the P11 master key. So on slide 6, what I want to bring together here is this idea that the master key that's stored in the hardware must be in sync and associated with the key store. So as we store key material in the CKDS or PKDS, those secure keys are going to be encrypted under the appropriate master key. And it's critical that an hour later or a week later or a month or a year later, when you want to use one of those operational keys, that same master key must be available to decrypt it. And ICSF needs to be sure that it has the right master key to be able to recover your operational keys. So the way that things work is when you load a master key into the hardware, ICSF is going to generate a hash of the actual master key value, and it will use that to represent the master key. Once you load a master key, there's no way to pull it out. You can't see what the original value is. So the way ICSF keeps track is by using this hash value. So when the key store is created, when the key store is initialized, the hash pattern of the master key that's associated with it will be stored in the key store, in the header record. So as you can see here, LPAR1 in the blue there on the top line is associated with a CKDS and a PKDS down there at the bottom. The hash or the master key that's loaded, the DES master key that's loaded, has a value of ABC, and the hash that represents that master key is 3ABLE5FOX. Down there in the CKDS, that 3ABLE5FOX is stored in the header record. When ICSF starts, it will go look at the master key value, calculate the hash of what's in the hardware, and compare that to the value in the header record of the key store. If they're the same, ICSF knows it has the appropriate master key, and it can decrypt the DES keys that are stored in the key store. Same thing with the AES master key. That hash value of 3493 is stored in the header record of the CKDS. The same thing applies to the RSA and the ECC master key. Those are stored in the header record of the PKDS. Notice LPAR 15 and LPAR 6 on this slide are both colored in gray, and they are associated with a single key store down there at the bottom, the CKDS. So what can happen here is we could create a key on LPAR 15. It would be encrypted under the master key associated with LPAR 15. In this case, it starts with EFG and has a hash value of 719ABLE. If a week later we want to run a job on LPAR 6 that uses that key, LPAR 6 can retrieve the record from the CKDS, decrypt it using the same master key value of EFG, and recover the original operational key value. The point here is that LPAR 6 and LPAR 15 each have their own section of storage on the Crypto Express card. LPAR 6 has its copy of the master key loaded in the register 6 or usage domain 6. LPAR 15 is assigned a different register, a different usage domain on the card, but the same values loaded there. So a little bit later on, when we talk about using the ISPF panels to load master keys, the point is you will need to physically load your key material on LPAR 6 and LPAR 15. With the latest versions of ICSF, there's been some enhancements called coordinated KDS administration, which can make the process of loading and managing your master keys across a sysplex much easier, but you still must physically load that key material from each independent LPAR, because LPAR 6 cannot access the master key that's assigned to LPAR 15. LPAR 15 cannot access the master key material that's assigned to LPAR 6. They must be loaded the same master key value, but at different registers. As you can see on this chart, there's 5 master keys that are supported in the current versions of ICSF. DES master keys encrypt DES keys. AES master key encrypts AES symmetric keys. RSA master keys encrypt RSA private keys. ECC master key encrypts ECC private keys. The P11 master key supports or protects PKCS 11 key material. The only way you can load a P11 master key is via the Trusted Key Entry workstation, and we'll touch on that a little bit more in a minute. But the other 4, you can load those a couple different ways that we'll get into in a second. And then finally on this slide, notice that each of the 4 master keys that you can manage from the ISPF panels, there's a current, new, and old master key register. The current master key is where ICSF will go when it needs a master key. That's the current master key is the one that is in use today associated with the key store. The new master key register is when you want to change a master key. ICSF will use this register to build or pull pieces together inside this register, and you'll see how that works as we go through the slides today. And then finally, the old master key register is kind of a one-back support. When you change your master key, before you bring the new master key into the current master key register, ICSF will take a copy of the current master key and put it in the old master key register. And it turns out that ICSF has some smarts. If the new master, or if the current master key does not match the key store, it will check that old master key register and say, hey, did we somehow get out of sync? And if we did, by comparing the verification patterns, he can tell that, okay, the old master key is the one that's associated with the key store. It can use that old master key. But that's not a situation you want to get into. And as we go through the process of loading master keys, the whole process is designed to make sure that your current master key register and your key stores are always in sync with the correct key values. Let's go to slide 7. As I've kind of hinted at, there's 3 ways to load your master key material. Now, the bottom one there is the Trusted Key Entry workstation. You must use that if you want to load P11 master keys or PKCS 11 master keys. You can also use it for the other 4 types of master keys. To use the TKE, that's a separately licensed or separate hardware product and LIC that you must order and purchase from IBM. It's a workstation with its own Crypto Express card that you must install and manage. And by manage, I mean you need to define users, you need to authorize what users can do on that workstation. So it adds a level of complexity to the process, but it is the most secure way to load your key material. You can create a new master key inside the secure tamper-resistant boundary of the card in the workstation, and then securely push that directly to the Crypto Express card on the host system. And it will never exist in the clear except inside the tamper-resistant cards. So we're not going to spend any time talking about the TKE today. That's a whole nother and probably much longer session. But what we are going to talk about are the other 2 methods, passphrase initialization or PP-init. And then just via the ISPF panels, there's a sequence, a number of utilities that you go through to generate random numbers, and then put those into the key, into the registers. And we'll talk about that, and we'll contrast those as we go through the rest of the session today. Let's go to slide 8. So when do you need to load master keys? Obviously, the first time you set up a cryptographic environment, if you're bringing up your brand new Z system, you've got Crypto Express cards, you're going to have to get the master key material loaded. In addition, you might need to load a master key when you go to your DR site. So you've got your system up and running. Everything, the master keys are loaded, the key stores are initialized, everything's in sync. For a DR, you would dump your key stores to tape, carry them to your DR site, and restore them. But to use them to unlock those key stores, you're going to have to load the master key material at the DR site and get it into the registers of the Crypto Express cards that you're using at the DR site. So that's a second scenario. The third scenario would be if you are installing new or replacing hardware in your existing environment. Once again, you're up and running, you've got Crypto Express cards, you've got master keys loaded, they're in sync with the key stores. Let's suppose you got 2 Crypto Express cards and one of them has a hardware fault. You would order another card from IBM, install that. If you remember when we talked about the hardware, you can just pop it into the machine and it'll recognize that it's there. But to use it, you've got to get those master keys loaded so that any work that's done on that card, when they retrieve a key from the key store, they will have the appropriate master key to decrypt it. Similarly, let's say you're running along fine with 2 Crypto Express cards and they are getting busy and the utilization is starting to go up and approach 100%. You might order another card to add some more capacity. When you install that card in the machine, it's not going to have any master keys loaded. You would have to load the master keys so you can start using that card. So those first 3 scenarios, you can use either passphrase initialization or the ISPF panels to get that key material loaded. Either process will work. There's a couple other areas where you might want to load master keys, and that would be if you're doing a master key change. Whether your security policy calls for a key change, your policy might say that, okay, every 1 year or every year or every 2 years or maybe every 5 years, we need to change our master keys, and that's just a normal operational procedure. Or if you have a suspected compromise, for some reason you think key material might have been exposed, or maybe if you just have a personnel change, maybe you've got a couple key officers. If one of the key officers leaves the organization, maybe they hit the lottery and they retire, or maybe they leave for other reasons. Maybe they're not happy in their job. That's probably a good time to consider changing the master key as well. So those more routine changes can only be performed via the ISPF panels or the TKE. But the point is you cannot use passphrase initialization to change your master keys. It's only for initial setup, getting things up and running. So keep that in mind as we go through. We're going to talk a little bit more about why pp-init is not a good way to run your production environment. Let's go to slide 9. So we're going to start talking about this master key entry process. We're going to start with pp-init, which is option 6 from your ICSF main menu. We're going to go to slide 10, and I'm going to take a drink here. So this is the pp-init panel. Up there at the top, you enter your passphrase. It's anywhere from 16 to 64 characters. Leading and trailing blanks are going to be stripped off, but any blanks within the passphrase will be preserved. Punctuation or uppercase, lowercase will also be honored. So if you capitalize everything, the next time you want to use that passphrase, you need to capitalize everything as well. In this case, I used a mix of upper and lowercase, and I've got to always use that same mix. Now, the first option there is initialize system. That's what you would typically use for a first-time setup. You select an initialize system, you point to your CKDS and your PKDS, and what ICSF is going to do is it's going to take that passphrase, it's going to run it through a hash algorithm. Actually, it's going to run it through a couple different hash algorithms. The process is slightly different for each of the 4 master keys. And then it's going to pull bits and bytes out of those hashes to be your key material. So it will pull those bits and bytes out. It'll create a master key for the DES master key. It will create a different one for the AES, a different one for RSA, and a different one for ECC, but all based on hashes from Crypto on System Z rocks. That master key material will then be inserted into the current master key register. And as we pointed out earlier, ICSF uses a hash of the actual key value. So whatever the master key that was calculated was, it will run a hash against that value, and that will be stored in the header record of the CKDS and the PKDS. So once this process is complete, you're going to have your master key loaded into the hardware, and the hash that represents each of those master keys will be written to the header record of the key store. Now, option 2 down there, reinitialize system, you would use that, say, if you were going to a DR site. So at your production site or at your main site, you brought the system up, you used the passphrase to set up the environment, the key stores are initialized with the appropriate hash. You would dump those key stores to tape, carry them to your DR site and restore them. Now, once you bring up the operating system and bring up ICSF, the hardware at the DR site, you don't know what the master key is inside the hardware, whatever the last guy that used that hardware left it as. So you have to get your master key loaded. By selecting reinitialize, and you would point to the CKDS and PKDS, ICSF will go through the same calculations, run the same hashes, pull the same bits and bytes out to generate the same key material. But at the DR site, instead of initializing the key store, it'll simply check the hash of those calculated values against the header records. And if they match, then it will insert the key material into the Crypto Express cards at the DR site. And once again, your environment will be set up. Your master key material will be in sync with the key stores. The third option there is adding coprocessors. As we described a minute ago, if you had a system up and running with 2 Crypto Express cards and you ordered a third one from IBM, you would install that card in the machine, and then you would come back to passphrase initialization, specify your passphrase, and select add coprocessors. ICSF is going to continue using the Crypto Express cards it's got, but it'll perform the same calculation as it did before, calculate the master key material, and insert those master keys into the new hardware. It won't touch the existing hardware, it won't touch the key stores, but it'll get that new hardware online and the master key material loaded so you can start using them. And then the fourth option there for add missing master keys, if you are migrating from, say, older hardware that didn't support AES or ECC encryption, you would have your DES master key and your RSA master key loaded based on the passphrase. Now you've got this new hardware. You need to get the AES and or elliptic curve master keys generated from the same passphrase, inserted into the hardware. And that fourth option would do that for you. So back to initialize system, you select initialize system, point to the key stores, and you hit enter. And we go to slide 11. And down there at the bottom, you'll see the messages that the master keys have been loaded. Everything is done. Passphrase is complete. At this point, you're up and running. You've got your master keys loaded. You can start putting keys into your key store. Let's go to slide 12. There's a couple problems with PPNet. As we already mentioned, it only works for a new environment where you want to load master key material for the first time or get it into the hardware for the first time. The second issue with it is that anyone and everyone that knows your passphrase effectively knows your master key. That is, the algorithms that ICSF uses to calculate the hash from the passphrase and to pull the bits and bytes out is documented in the ICSF Systems Programmer's Guide. So if you go to your DR site and type in crypto on System Z rocks from a console to get things up and running, if there's an operator or somebody from the DR company looking over your shoulder and they see crypto on System Z rocks, they could go calculate your master key material. So that's not considered a real good environment. You want more security around the process. And we're going to see in a minute that the ISPF panels give you the ability to load multiple key parts that come together so that no single person knows your master key value. Each key officer will know their key part, but it would require collusion among the key officers to calculate the actual key value. And the reality is no one needs to know your master key. The hardware needs to know your master key. The hardware needs to be able to decrypt the operational keys out of the key store, but only the hardware needs access to your actual master key value. And that's what the ISPF panels or the TKE can do for you. Let's go to slide 13. So we've loaded our master keys using passphrase initialization. We can look at the crypto hardware from the main menu. We select option 1, coprocessor management. And on this slide, on this panel, we would see all of the Crypto Express cards that are assigned to the LPAR. In this case, there's 2 of them. And we're going to put an S next to both of them for show. You don't want to do D for display because D stands for disable. You want to do S for show to look at the contents. Slide 15. And the first screen we see is for the AES master key. Note down at the bottom, the current master key register is valid. That is, the master key is loaded. It's in sync with the key store. And the verification pattern that represents the AES master key starts with Fox03 Charlie. And that same master key is loaded in both G06 and G07 on the right. If we had more Crypto Express cards, we could scroll to the right and hopefully see the same hash patterns. Notice that the new master key and the old master key registers are empty. That is, we've not put any key material into the master key register, and the master key's never been changed because the old master key is empty, or the old master key register is empty. If we scroll down, on slide 16, we see the exact same information for the DES master key. Now, the verification pattern, the hash pattern, the terminology is a little bit different, but in a nutshell, each of those patterns represent the key material that's stored inside the card. So let's go to slide 7, which is, if we page down, we would see the same information for the elliptic curve master key, and then page down time to slide 18, and the asymmetric or RSA master key. We see the hash pattern that represents what's been loaded there as well. So now we want to go through a master key change. Let's go to slide. A good master key, or a good key in general, is a random number. It's not a value that's easy to remember like ABCD. It's a random number. Those just make good keys, or as we're going to see, they make good key parts. Fortunately, the Crypto Express cards can generate a random number for you. There's a hardware engine on the card to generate random numbers. Let's go to slide 20. That random number generator is provided as a utility within ICSF, so we would select option 5, utility. And then on slide 21, we would select option 3 for generate a random number. And on slide 22, when you first come in, the parity option is going to be blank. We haven't talked about it before, but DES algorithm requires that the DES key be odd parity. That is, every byte must have an odd number of bits in it. Now, there's not the same issue with AES and ECC, but it only applies to DES. So generally, I just tell people, put random in here and just generate a random number. When you start XORing key parts together, you might end up with an even parity DES key. But that's okay because ICSF knows that the DES algorithm requires odd parity, and it will flip a bit to make sure that you end up with an odd parity master key. So you don't really need to worry about, it doesn't really matter what you specify here. It's going to take care of you in the long run anyway. So if you put in random and hit enter, that'll take us to 23, and the ICSF has gone out to the Crypto Express card and had it generate a random number for us. Now, at this point, we could be creating a DES master key. We could be creating an AES master key, which is 256 bits long. So we would need all 4 of these random numbers for an AES key. We only need the first 2 for a DES key. So we've generated a random number. The next step would be to calculate a checksum just to make sure we don't have any finger checks. So you'd go back to that utility menu, and option 4 on it is a checksum calculation. And we can see that on slide 24. You would have gone back to utility, entered 4 for checksum. When you come in here, the key type is blank. The key value, if you've configured your ISPF environment correctly, the key value would be remembered and it would be already plugged in here. If it's not already there, then you've got a problem with the configuration of your TSO proc and how the panels and the ICSF support's been implemented. If you leave the key type blank, you'll get a list of all of the different keys that ICSF can generate a checksum for. For this exercise, we're going to load the DES master key, so we key in DES MK-MK to say I want a checksum specifically for a DES master key. If you hit enter, you get to slide 25. Now notice that the third and fourth key values have been zeroed out because the DES master key is only 16 bytes long. So it's only going to use the first 2 input key values to calculate the checksum and to be the master key. And in this case, the checksum is dog dog, and the key part verification pattern for this random number as a DES master key starts with able 751. All right, so this will be just used as kind of a finger check. You know, if you have to carry this to your DR site, you might mistype one of those values. You know, you might type 03 able instead of 02 able, and the checksum will help capture that. So now we want to load this value into our hardware. Let's go to slide 26. So we're going to go back to the coprocessor management panel, and this time instead of entering S for show, we're going to enter E for enter. Now, I see it. You could just put an E next to G06 and go through the process, and ICSF will load that key material into G06. Or in this case, where you got multiple coprocessors, if you put an E next to both of them, ICSF will go through the same panels, but it will make sure that that key material gets loaded into both cards, not just one card. So if you've got 6 or 7 coprocessors assigned, you could put E next to all of them, go through this sequence of panels, and it will get that key material loaded into all 6 of them at one time. Let's go to slide 27. So notice up at the top that all of the keys, all of the new master key registers, and specifically the DES new master key register is empty. That is, we have not loaded any key material into this card. Notice also the checksum and the key value are already populated. So if you came directly from the random number generator and the checksum utility, as long as the ICSF panels have been configured correctly in the logon proc, it'll remember the values and plug them in for you already. Now, at this point, we want to tell ICSF that we're going to load a master key and the part values. So let's go to slide 28. For the key type, we put in DES master key. We're going to specifically use this for the DES master key. And because the new master key register is empty, we must specify first as the part. Now, you can have as many key officers as you would like. You could have 99 different key officers. Now that probably is a little bit hard to manage operationally. The first key officer to load their key material, if the new master key register is empty, he must specify first. And the last key officer must specify final. That tells ICSF, okay, we've entered all of the key parts. Go lock that register. Don't allow any more changes to it. The other 97 key officers, 2 through 98, would enter middle. And as they enter their key parts, they're just going to get XOR'd to what's already in the register. So the first key officer comes in, specifies DES master key in first, the checksum and the key value, and they hit enter. And we get to slide 29. Notice now that the DES new master key register is part full. That is, there's a key part in here, but we're not done entering key parts. The checksum and the key value have been zeroed out. There's no need for anybody to see those on the screen anymore. And there's a new line down there. The entered key part verification pattern was ABLE751. That was the verification pattern that represented this key part. So it's just another check that you haven't made a typo as you load your key material. So at this point, key officer 1 is done. Key officer can log off and go home. And at some point later, key officer 2 and 3, and we're going to use 3 today for our example, they could come in and log on and continue with the next slides. You could even have an IPL in between. You could have a power on reset. That first key officer's key material has been loaded into the card. It's there. It's protected by the battery-backed RAM. If you have an IPL or an outage, that key material is not lost. It's still there. So let's say it's the next day. Key officer 2 comes in and logs on, and we go to slide. Now, they're going to go through the same process we just went through to generate a random number and to calculate a checksum for that random number. So key officer 2 is going to do the utility option, random number, and checksum. They're going to have their own unique key part, which in this case starts with a Charlie Easy 54. And the checksum associated with it is Fox Fox. Now, since they're doing the second key part, they're going to specify a part of middle to say this is the middle part. Notice also there's a reset option there for part. If you decided, somebody messed up, they used the wrong key part to get started, you could put reset in here and ICSF will wipe out the contents of the new master key register and let you start the process over. But we want to proceed on. So key officer 2 has entered his key value and his checksum, and he's doing the middle part. He hits enter. We get to slide 31. Again, the new master key register is still part full. The checksum and key value have been zeroed. Nobody needs to see those anymore. They've been loaded. And the verification pattern associated with this second key part was 8EASY86. And that is just another check to make sure that you didn't make a typo. So now the third key officer comes along, and let's go to slide 32. They're going to generate a random number and a checksum, and they're going to load that into the hardware as well. Once again, they're going to specify the key type of DES master key. They're also going to specify this as the final key part to tell ICSF, go ahead and lock this key register. Don't let any more changes come along. And it's going to XOR this Baker Fox 57 with what's already in the new master key register. So if we go to slide 33, now the DES new master key register is full. It's no longer part full, which says you can't add any more key material. You could do a reset at this point and start over, but you can't just add any more key material. The entered key part verification pattern is the 3 Fox Fox Easy. That represents this third key part. But now there's another line above that which gives you the verification pattern for this new master key value. So the contents or the 3 key parts have been XORed together to create a master key. And this string Baker 007 that starts with Baker 007 represents that new master key material. That is the value that's eventually going to be stored in your key repository. So one of the things that we recommend you do as you go through this process, either when you calculate the checksum, which has your key part, as well as the checksum and the verification pattern that represents it, when you create that, do a screen print of that page. So you have a hard copy of key part 1 and its associated checksum and verification pattern. Do the same thing for key officer 2. Create a hard copy of the key material, the checksum, and the verification pattern. And the third key part, the same thing. Then what these key officers can do is once they load their key material, key officer 1 would take his hard copy and put it in an envelope and sign his name across the seal of the envelope. That way you can tell if it's been tampered with at some point in the future. Key officer 2 would put his page in a different envelope, seal it and sign it. Key officer 3, the same thing. Then one person, an ICSF administrator or one of the three key officers, would take all three envelopes, put the three envelopes into a bigger envelope, seal that, and across the seal, write this verification pattern of Baker 007. That way, if at some point in the future, let's say you take your key store to your DR site and you don't remember what the master key associated with it is, you could dump the header record of the key store, see the Baker 007 easy value, and then you would know, all right, I need the envelope that has Baker 007 on the outside, and I know if I open these envelopes up and load those three key parts, I will recover the master key to unlock the key repository. Now, you might even do two envelopes. So you would have the three key parts in an envelope and stored in a bigger envelope that's stored at the production site. So if you have a hardware outage, if one of your Crypto Express cards go down, you install a new Crypto Express card, you could open the envelope up and load your master key material. You might have a second copy stored off-site somewhere at the DR site or somewhere remote from the data center, so that if you lose the data center, you've got that key material. So how many copies you need depends on your level of paranoia, but I would recommend having 2 copies of the master key parts. Keeping in mind that with those 4 master keys, if you have the original key parts, you can unlock the potentially thousands of operational keys that are stored in your key store. So that's the process of loading your key material. Let's go to slide 4. We can go now look at the contents of the Crypto Express cards again, put a show, S for show, next to both of them. And notice here for the DES master key, the current master key has the same value as it had before. We have not changed our master key. We have only loaded these key parts into the new master key register, and we see that Baker 007 verification pattern that's associated with, that describes the master key that's in the new master key register. So again, we're still running on the original master key, but now we have our new one loaded. If you're running in a sysplex, you would have to go to each system in the sysplex and go through this key entry process. You don't have to repeat the random number generate and the checksums, but you've got to load that same key material in every member of the plex that is sharing that CKDS or PKDS. Once you've got that loaded, now you can go through the process of actually changing the master key. Let's go to slide 36. To do a master key change, after you've loaded the new master key material, you go to option 2, master key management, master key set or change. And the first screen you'll see if you're running HCR 77ABLE0 or later is this one. Now at this point you can mess with either the CKDS and the DES AES master keys, or the PKDS and the RSA ECC, or the TKDS and the P11 master key. So we did the DES master key, so we're going to choose option 1. Now if you're running in a plex with HCR 77ABLE0 and later, there's a capability called coordinated key administration, which means the process for changing master keys across the plex is much, much simpler. To do this, there's a couple prereqs. First of all, everybody that's running in the plex must be at least at HCR 77ABLE0 or higher. That's where this support was fully implemented, so you've got to be there. Every member of the plex must be pointing to the same set of key stores. You could have a unique key store for each system, but if you're using a common key store, what ICSF will do is it will manage the master key change across all of them at the same time. In addition, not just pointing to the same key store, but they've all got to be running with the same current master key, which makes sense. If the key store is associated with a particular master key, that master key must be loaded on all of the cards, on all of the plexes. And you've got to be changing to a single master key. So the new master key must be the same on every card, on every LPAR in the plex. And then lastly, you can't be running in compat mode yes. If you remember, compat mode yes provides some support for some old crypto architecture, but one of the problems with running compat mode yes is you cannot do dynamic master key changes. So you've got to be running compat mode no. If you're running compat mode yes, it won't work. But assuming you are, ICSF is going to coordinate that master key change. And even if you're not running a shared Plex, the processes, the panels you're going to go through are still pretty much the same with a couple comments that we'll get to. So on slide 39, we selected option 1 to do the CKDS, and now we want to do a coordinated CKDS change master key. And we're going to change the master key across all, let's say we have three LPARs sharing a CKDS. On slide 40, we already told it we're going to mess with the CKDS, so it fills in the KDS type of CKDS. Then we point to the active KDS, the active CKDS in this case, the key store that is associated with the current master key. In addition, we point to the new KDS or the new CKDS, which is going to be initialized and built and associated with the new master key that's in the new master key register. What's going to happen is as part of this process, you're going to do what's called a re-encipher. ICSF will read each record in the active KDS, the current CKDS, decrypt it from underneath the current master key, immediately re-encrypt it under the new master key, and write that newly encrypted operational key out to this new CKDS. So when this process is done, you're still going to be running, well, you're going to have your operational keys will be encrypted in the new CKDS underneath or encrypted under the new master key register. When you start this process, the first thing that ICSF is going to do is it's going to put an enqueue on the key store so nobody can update it. It's still available to be used for read, so crypto processing can continue while this re-encipher is going on, but you won't be able to insert a new record into the key store. You won't be able to change a record in the key store because you could run into a situation where somebody could come in and change record 5 after you've already read it and re-encrypted it under the new master key. So it's going to perform an enqueue, and ICSF, if you're running on LPAR 1, is going to tap LPAR 2 and LPAR 3 on the shoulder and say, hey, we're going to do a master key change right now. You put an enqueue on the key store. Don't let anybody update it either. ICSF is going to perform the re-encipher. When it's done, LPAR 1 is going to take the current master key, move it to the new master key register, or move the current master key to the old master key register. Then it's going to take the new master key, move that into the current master key register, and it's going to read this new CKDS and build a data space with all of those records, those keys encrypted under the new master key, get that into a data space, and then it's going to flip the switch and start using that new key store along with the new master key. He's then going to tap LPAR 2 and LPAR 3 on the shoulder and say, hey, here's the new CKDS. You go read it, build your data space. You make the change as well. Move your current to old and new to current. And then he'll tap LPAR 3, and LPAR 3 will do the same thing. When the process is done, he'll release the enqueue, so any updates or adds to the key store will go ahead and be processed at that point, and you'll be running on your new master key on all 3 members of the Plex. Very nice, very smooth. We're going to touch in a minute about some of the things you have to do if you don't use this coordinated KDS administration. But before we do, I want to point out the rename active and the create a backup. One of the problems that customers had prior to this support was when they created this new key store, ICSF would be running on the new key store. Now, if you remember, the options data set points to the CKDS and PKDS that ICSF should be using. If they forgot to go back and change the options data set to point to plex.new.ckds, the next time ICSF was stopped and restarted, it would point to the old CKDS, but the new master key was loaded into the current master key register, and ICSF got unhappy because they weren't in sync. If you say rename active to archive, ICSF will take your original CKDS, the plex.test CKDS, and rename it to the archive copy, whatever you specify there. Then it'll take plex.new CKDS and rename that to the original name plex.ckds. So if you use that option, you don't need to remember to go back and change the options data set. And you still have the archived version, you still have the old version, so if there's a problem or something and you should need to fall back, the original CKDS is still there. Then the next option, create a backup of the re-enciphered KDS. It's a small risk, but one of the risks that customers ran into was if they did a key change and they created the new CKDS with all of the keys encrypted under the new master key, when would that data set get backed up? Now, probably maybe overnight in the overnight backups, or maybe the following weekend, when a weekly backup. But the point was they didn't right away have a backup copy of this newly encrypted KDS. So by specifying yes for create a backup of the re-enciphered KDS, when ICSF finishes re-enciphering and building the plex.new CKDS, it will immediately invoke idcams and make a backup copy of it, just so if you have a hardware fault on that volume an hour later, you would hopefully have that backup on a different volume and you would still have your enciphered KDS. So this coordinated KDS administration has greatly eased the process of changing the master key, doing all of the steps that you need to do to change the master key. Slide. We've got kind of a summary of that process. So we talked about generating the key parts and calculating the checksums. Then you've got to load those key parts into the hardware, into each device on each LPAR that is going to be sharing your key store. Now, we didn't talk about disabling the CKDS access except to say that ICSF would do it for you. If you're running on an older version of ICSF, there is actually another panel that you have to use called Admin Control. It's option 4 on the ICSF main menu. You would go in there and say, all right, disable the access update authority to the CKDS. Once again, ICSF would continue using the CKDS and can continue reading and getting data, and cryptography could still go on. You just couldn't create or change any keys in the key store once this access was disabled. Then you perform the re-encipher, read the current CKDS, decrypt the records from underneath the current master key, re-encrypt them under the new master key, and write the newly encrypted value out to the new CKDS. Then you would actually perform the change. Once again, if you're not using this coordinated KDS administration, there was another panel that you had to go to and say, all right, let's change the master key. And then you would have to go to each member of the Plex and do that actual set and perform the key change on each member. With KDS administration, it's much easier. And then you would have to re-enable the KDS access so that people could continue go on making updates and adding and inserting new records. And then once again, if you didn't use that the KDS administration, you would have to go manually change the name of your CKDS and PKDS in the options data set to make sure that the next time ICSF comes up, it's pointing to the newly encrypted copy of the CKDS. Let's go to slide 42. So some things that you need to think about as you're implementing your master key change process. The first obvious one is, how many key officers are you going to have? Um, you can cheat the system, and you could have you could use the ISPF panels, and you have two key officers, and they could be the same person and generate two random numbers and XOR them together. Doesn't take much collusion if it's the same person. I think you probably need at least two and maybe even three key officers. Much more than five is probably going to be hard to manage. The next question, how are the key parts generated? If your key officers are not familiar with TSO and ISPF, they may stumble through the process of generating random numbers and checksums. So I know of at least one shop that what they did was they had a key officer would go out and for their three key administrators, they generated 30 random numbers and calculated 30 checksums, and they did a screen print on all 30. And then the administrator handed 10 of those key parts to key officer one and said, pick one page, throw the other 9 away, burn them, and load your key part. And key officer 2 got a second set of 10, and key officer 3 got a third set of 10. And each key officer only had to manually go load their key material. They did not need to generate random numbers and checksums. It just kind of depends on the skill level of the people that you have performing the process. Where are you going to store your keys? How many copies of these key parts are you going to have? So as I described, I would have at least 2 copies, one stored securely, maybe in a safe at the production site that could only be opened if there was a hardware problem or new hardware installed. Another copy or another set that would be securely stored off-site, whether it's at SunGard or IBM, whoever your DR provider is, or maybe the senior security officer takes them home and locks them in a safe at home. Whatever's right for your organization. But the bottom line is, if you need to reload your master keys, that master key material, those key parts, must be available to do that. So how often are you going to change your master keys? It's a common question we get. In Canada, there's actually a law that for certain financial related institutions, they have to change their master keys at least once every 5 years. There's no similar law in the United States. I think 1 year or 2 years is reasonable. The other comment I'll make is that if you perform a yearly DR exercise, if you have to load your key material at the DR site, you have to open those envelopes and get that key material out. Maybe once the DR exercise is over and you're back running on, back at your production site, that might be a good time to change the master keys, because maybe somebody left those key parts laying out for 5 minutes and maybe they got exposed. Kind of unrelated to master keys, but you also have to think about how often you're going to change application keys, because they should probably rotate as well. If you're running HCR 7780 or later, and you have this coordinated KDS administration support, that greatly eases the process of changing the master keys across the Plex. I think that alone is a good reason to move to HCR 7780 and get the support for doing coordinated KDS administration. It makes your life much easier. And then finally, don't forget that crypto ought to be a part of your change management. So if you're going to implement a hardware change, clearly the key officers need to be available at some point to get the key material loaded into the hardware. But even if you're just making operational changes, there may be aspects of crypto that you got to worry about, and there ought to be some kind of a checkoff to say, do we have the key material available to support this change? If it's an application moving from LPAR 1 to LPAR 5. Crypto needs to be considered as you make changes to the whole environment. Let's go to slide 40. So in summary, this master key change process is not hard. It can be intimidating. You're scared that, if I make a mistake, I could bring things down. But the process is fairly robust. There's a lot of self-checks built in, from checksums to when ICSF starts and it checks hash values. So I won't say it's bulletproof, but it's fairly easy to go through the process and get it done. You should have a security policy that describes or defines when you're going to make master key changes. It should be clearly documented. Your auditors will like that. Um, you should not be using passphrase initialization. It's a great way to get up and running, but for a production environment, you ought to be using the ICSF panels or the TKE to change your master keys. And it should be well documented. If you have an outage, if you have a problem, maybe a compromise, there's going to be some pressure to make the master key change fairly quick. So the process ought to be very well documented. So in the middle of the night, under the pressure, you can smoothly go through the process. And then finally, as we've talked about a couple times, that master key material must be available to recover your environment. Whether you're installing new hardware, replacing hardware, or going to DR, those key parts have to be available to get loaded into the hardware. Make sure you know where they're stored and who has access to them. And slide 44 is a couple references. The tech docs, there's a couple different passphrase generated. They'll display your passphrase, the master keys that are generated from the passphrase. I wrote an article for Enterprise Tech Journal about a year ago that talks about why passphrase is not a good option. And then up at the top, you've got your ICSF manuals. So with that, I'm going to turn it back over to Jerry and let him open things up for questions.